Oh.
Bueller.
Oh, hey everybody, welcome back to Sunday Science on a Tuesday, as always. I appreciate everybody hanging in there the last couple of weeks that vacations have been taking place and people have been rummaging around in the wilderness and in the great north and having fun adventures. I was hoping one of our other friends would join us that happened to be doing some adventuring on the other side of the pond, but perhaps we will be able to snag Hillel at a later date. In the meantime, as I say, welcome back, and I hope you guys enjoy our presentation for this evening. I know it's a little bit later in the evening than we usually try and do things, but it is summertime. Things have been busy for everyone, and sometimes you just need a little bit of leeway.
And some of us get sinus infections that won't go away, you know, that kind of stuff.
Oh, that's terrible, Stephen. Sorry to hear that.
It's all right.
Sinus infections are never fun.
Oh, no.
No, they aren't.
Well, so last time we left off, we were still in the midst of discussing our radio astronomy project, and I assure you that is still going full swing. I'm not sure how many radio guys are going to be joining us today, but there is progress made in various regions. I believe SciStrike's a couple of steps ahead of me, but I will be picking up a 1980s My Generation Meade powered right ascension mount tomorrow, so that I'll still obviously have to handle some things manually, but at least it is a powered right ascension, so I can leave it alone all night and let it do its thing. So mounts are coming together, dishes are up, and it sounds like we're both starting to move into the software and receiving end and getting ready to start running some tests. So while that's all been being built, a few other things have been taking place. Like I mentioned, vacationing and wandering the amazingness that is Scientific America. And, well, that's exactly what I've been doing. So wanted to share with everyone tonight before some of this science project gets finished with actually getting receiving up on the way and actually getting signals received, getting actual software potentially developed. Basic, obviously not. I don't know SciStrike's level of software producing capabilities, but I toy around with a little bit of open stuff and open source stuff. That's about it. But that's eventually where this project's going to lead. So it's going to be a lot of fun to stick around and see how things go. Just remember, it might be a little bit of a slower project than sitting down and watching someone like, some other people I don't want to infringe upon.
I wonder how many people are building along with us. It sounded like there were 2 or 3 the last time we were broadcasting that were.
Is Bo?
Oh, I would not be surprised if Bo's not done and already has a complete, 2-dimensional sky map. That would not surprise me one bit. But
that would not surprise me one bit as well.
But anyway.
But it is a fun project, and with some of the fun that I was able to have, over the last 2 weeks, there are going to be some special links in the description for some easy projects if you're looking at joining in on amateur radio astronomy. SciStrike should have an absolutely phenomenal link. I was able to gain this one by visiting tour stop number, well, it's like number 7 as far as my last road trip is concerned. However, a lot of what I was doing was going and spelunking in southwest Colorado and north central to central New Mexico. So a lot of the cave fun, as amazing as it was, isn't as scientific, but it's still a fun thing to sit down and share, especially having a geologist on the show. So SciStrike, if you don't mind, I might go ahead and start sharing a window here and
All right, very good.
showing off some of these things. I did want to take video when I was at one particular location. However, it's a radio silent area, so if you haven't figured that out already, don't pop any spoilers into the comments. We will get to it and we will be there because it is a tremendous amount of fun. So if I'm presenting, hopefully everyone's seeing the moon and Jupiter because that's what my camera defaulted to, or you're seeing nothing.
Actually, we're seeing your Hangouts screen with us.
Yeah.
Well, that's not the right
one.
That's just...
Okay, good grief.
Yeah, you want to share a window.
That's probably going to wind up popping the chat up, let me guess, since I put the chat in front of the...
There's the chat.
Yep. There it is.
Yeah. Okay, I got to close the chat so that I can... I don't know why that's going the way it is. That's kind of a nuisance.
All right, I'll keep an eye on the chat and notify you if there are any specific questions for you, Andy.
Well, now I just got downgraded Windows even more. What in the world? All right.
Oh, there's Bo calling CQ.
There we go.
All right, whoa, look
at
that.
Share my whole screen and then just decide you only get to see half my screen instead of my whole screen. That
you are presented.
All right. So, yeah, this was not part of the this was returning home from the vacation. Sorry, it's where my camera starts, and moon, Jupiter. I love astrophotography, so you guys all get to see that as well. Hope you enjoy it. I thought it was dead pixel for the longest time, but you can actually, down in the bottom central frame, you can see the difference between a dead pixel and Jupiter. Obviously, yes, that is Jupiter. So tell your flurfer friends, it's not a hard thing to take a picture of. Anywho, so outside of that, there was a lot of fun stopping through a decent amount of New Mexico, as many probably already know, but I'll go ahead and explain anyways. Obviously, the Trinity test site for the first atomic bomb was in New Mexico, Los Alamos Labs, where all of the Manhattan Project was ran out of in Los Alamos, all in New Mexico. So there's a lot of states that have museums about the kooky history of their state, including giant hairballs and buried cars and weird things, and they're fun roadside attractions, but I assure you, New Mexico has very few roadside attractions in that manner, but a lot of science. And one of the best places to check out if you happen to find yourself in Albuquerque, New Mexico, I hear the museum directly in Los Alamos is equally as impressive, but Albuquerque's used to be on the Air Force Base. It was moved after 9/11 security issues and whatnot. So this used to be on the Air Force Base. It's now moved into the public sector for security purposes. And if you're unfamiliar with a lot of Manhattan Project stuff, I'll see if I can find some other links to toss in this way, but this exhibit is absolutely phenomenal. Of course, there's some fun stuff that I'll pop in and show later, but that's There we go. So yes, there are, World War II exhibits built into everything, as you would expect. So I got pictures of those. I might skip through and jump around, but a lot of this is early work on the Manhattan Project recreated in a museum setting, of course. So you have sitting down and actually creating the plutonium spheres necessary. I wasn't alive then. I can't remember if everything was still uranium or if we were actually using plutonium. I'm pretty sure it was plutonium. Someone correct me if I'm wrong. But obviously you need a dense sphere, blah, blah, blah. I don't need to get the NSA on me or anyone. But this was a lot of the exhibit was just the early stages of developmental processes, what took place during Manhattan Project. Then most of these are actually from days of testing. They're not recreations. So you can imagine some of these components, these perfectly hemispherical shaped mechanisms used to actually sit down and condense highly radioactive material. These were all machined before CNC computer equipment existed. So this is processed by hand, and the level of craftsmanship and the precision necessary to do this, being in engineering, having worked as a machinist for multiple years, it's absolutely phenomenal to think about the amount of skill and knowledge of the trade that went into producing a lot of the vessels necessary for producing these things.
Andy, you have a question from Squirrel. He wants to know when this was, when you were doing this.
Oh, so I was just there that was the week of the 14th. So the 14th of this month.
There you go. I assume that was the question, not when was it that they were doing the design and experimentation.
I assume, sorry, I had to close out the chat, so I can't see it right now because it was overriding my little Windows media thing. I usually use Corel to show stuff, and chat doesn't override Corel, but apparently it overrides Windows Media for whatever reason.
Yeah.
So
I am Andy.
Did you have another laptop you could just turn on and watch it that way? Because that's what I do.
Well, I used to have a small flat screen TV that was plugged in, so when I made YouTube videos, I could see it a little bit more how I thought it would look. And HDMI really bogs down my driver cards for whatever reason. They really don't like using anything other than what's Apple's version? I always forget the it looks like HDMI, but it's Apple's version of HDMI. My video card doesn't like when I plug straight HDMI in.
Oh, really?
It gets slow. It's I'm somewhat computer savvy, but I don't know everything. I just know it enough to get around.
Correction. I said Squirrel was not asking when you were there. He was asking, are we talking about during or post World War II? The exhibits you've shown so far.
Yeah, the era of equipment.
So this type of equipment back here and this laboratory setup, this is directly from the Manhattan Project, so that would be during.
Okay, I told Lord Croc Squirrel was after. My bad.
Yeah, so that was all during. Again, like I say, there's lots of other World War II mementa that happens to be there. I'm a huge World War II buff, so I had to grab pictures. One of the first rifles you saw was actually from the Japanese Navy, but anywho, this one I thought was spectacular. Absolutely, this is this is an early multimeter from the U.S. Navy, and it's so easy this day and age to take for granted something as simple as a multimeter. You can run over to the big buck stores and buy one for $30. It's not that great. You can go get a deep, if you're like me, you're going to buy one from the company that starts with FLU, and I'm not going to finish that. And it lasts a lifetime. You're going to have it forever. And I'm sure this multimeter actually still functions perfectly. But it's just one of those fun things, you know, you take for granted how easy it is to just have a multimeter lying around. And it's really not been that long since that was actually a very, very sophisticated piece of instrumentation that you couldn't just go and get your hands on. So, yeah, there's going to be a lot of that. I'm a nerd. Look at this. Obviously, a DC amp meter. A lot of this stuff just it's so cool. Freak generate. Yeah. This was a bombardier sight from a B-29. You can imagine that's why you're at a nuclear history museum. Because of these guys. So, yeah, obviously weaponization, it did some havoc and is still doing havoc on the planet, but it also led to a lot of, that's the Trinity flag for anyone that's never seen it up close and personal or really recognized that it's a historical type of thing. This was the flag that was at the Trinity test site in White Sands, New Mexico when, let's see, I think I actually have it in a separate window, the Gadget. Yes, when the Gadget was the very first nuclear arsenal to be detonated, which this sphere is an absolute amazing feat of engineering, all on its own. I know the destructive capabilities, it shouldn't be the way that civilizations went, but it's what we did, unfortunately. But a lot of other good has come out of it, nuclear medicine, many other things. So sometimes yeah. So that would be the Trinity flag. Obviously, some more, you know, fun with gigantic cluster Fs. Early versions of missiles. All of these none of these are recreations at this particular museum. So if you ever get the chance to go to the National Nuclear Science and History Museum in Albuquerque, obviously, I shouldn't say nothing's a recreation. What does appear to be a recreation, such as Fat Man and Tall Boy, Little Boy, yeah, those are the others that were built and not used. So when, you know, generally you sit down, you build a prototype of something, you're not going to build one because if you make a mistake on one, you have to start from scratch. So you build 2 or 3. And those extras have a tendency to wind up in museums or spare parts, otherwise things of that nature. But a lot of these moving into the Cold War era, these are not duplicates, these are not recreations, these are either spent or decommissioned articles, and it's really fascinating to go and take a look at. So that's an actual retired warhead from a Triton II, which is bizarre to think about standing next to. Early developmental stages of how to fit something that used to consume that, now consumes that. So obviously technological advances during the time were absolutely amazing. And here you see a very early Triton. And one of the big reasons why I'm so fascinated with this particular mechanism in particular is all of the advancements that multi-stage rockets gave to the future of space exploration. It's unfortunate that sometimes you need the warmongers to give you the money, but sometimes you got to take the warmongers' money to create the science to do something positive instead of negative. So there was a huge amount of development during the Cold War, obviously, prior to any sort of space flight whether it's the Soviets or the Americans. Unfortunately, this was a lot of the technology and a lot of the financing necessary was the potential to kill everybody everywhere all at once, which is disappointing.
Are there any V2 rockets in there?
There were no V2s, but I am getting up on the outdoor exhibit. So this is the nose fairing that actually covers the warheads itself on an early Triton, which I kind of thought it was interesting. Just kind of, it really didn't need to be as aerodynamic as I assumed from early pictures of seeing Titan missiles as a child. Yeah. Anywho, moving. Okay, so not even actually as aerodynamic as an MK4 Minuteman. So for those of you that remember being taught to push the ladies under the desks so that you could make sure that they were covered when a Minuteman missile was launched, here's the warhead unused and the warhead after reentry. And again, one of those things, it's a terrible idea to think about nuclear war, but considering atmospheric reentry vessels, what sort of materials would need to be used to maintain cohesive electronic devices, things of that nature, this actually started leading the way for the ability for man to go into space instead of just weapons. So it's, yeah, one of those double-sided coins. Sorry, I said MK4. It was an MK5, a little bit later on, but.
Andy, another question for you. It seems.
Yeah.
Bo wants to know: were those RCS thrusters on that Trident? I couldn't see from the picture.
That I am not sure.
There's something for us to look into.
That is one, and I got closer pictures. There you go. So that's actually the primary on the Trident. Obviously it's been capped in some way, shape, or form, and it's been set to be a museum piece. So I don't know what just the bell fairing does for determining that shape. It's definitely not something I would be able to determine. Maybe a historian that's also a rocket enthusiast or rocket scientist would be able to just look at the fairing and go, this is that. I'm not capable of that. But I am capable of determining when you're standing right in front of a B-29. So this... Yeah, enough said. Okay. B-29. And it really didn't matter that it was about 111 degrees outside on that day, and it was horrible crushed white rock you got to walk around in. Yeah.
Sounds
awesome.
Fun.
Boneyard. What was that, Stephen?
It sounds fun.
It was an absolute blast. If I was skeptical on taking my Canon in, my Canon camera when I went in, just because I wasn't sure what would be allowed to be photographed, what would not. You know, it's Nuclear Science and History Museum. Things have been weird over the last couple of years, so I didn't want to take my camera in, but as soon as we got in and everything's available for pictures, so I did the best I could with my phone on these ones.
Gotcha. Were you able to walk up to that and touch it or no?
Almost.
Off.
Well, I'm maybe 2 inches taller than this guy, so I'm sure if I got my Michael Jordan Power Man jump on, I could have reached the wing, but it was so hot I had no interest in trying. There were others, though, within the exhibit that you could get up to. The B-52, you could walk right up to a B-52 and grab onto it. There was some maintenance going on with other things. I don't actually know any of these people, so my apologies. If anyone finds himself on YouTube and wants me to delete these pictures, I will. But then we got into more of the Tridents and the Titans. And they were just available for going and getting hands-on with however in the world you wanted. Obviously, you couldn't take them apart or anything weird, but it was a whole lot of fun going to this museum, being able to take a look at, obviously, this is a 3-stage rocket in a Titan II. Again, I can't stress how much I'm against nuclear warfare, but it did lead to an absolutely monumentous leap in man's spaceflight capabilities, and the scientific prowess behind it was in the right area. The devious nature of politicians is just not generally with science. So unfortunately that stinks, but you do get to have the option of sitting, or not the option. You do get the time to sit down, take a look at these vessels, how they were actually built, how they were crafted, what their history was, how they led into spaceflight as we know it today, how second stage boosters actually look inside of the full craft fairings, and what a Titan II on the operational end looks. And then you start getting into the engines and the engineering, and to remind you, this is down here in this little corner that is a tractor wheel for a semi, for an 18-wheeler. So I easily could have climbed inside of either one of these bell housings and taken a nap. They're enormous engines. I don't know exactly what engines in particular they are. There was obviously multiple series used throughout the times, but it is a phenomenal museum to go to, and if you ever get the chance, I highly suggest it. And outside of history, there's also a whole lot of fun there as well. Obviously. So, fun with DeLoreans, fun with movies, and on your entryway in, I do have to admit, if I ever have floor space large enough, this is the only periodic table I would ever need. These are all standard 12-inch by 12-inch granite tiles, and the entire entryway to the museum is...
That is the coolest periodic table of all time, because it's made of rock.
It is. I was so blown away by it. I couldn't help but sit down and take pictures of the whole thing. Everyone was looking at me like I was a weirdo. I was the only guy taking a picture of the floor.
I would have.
I'm surprised you were the only one.
Did you get a panoramic or some video or anything?
I didn't. I was hoping I could stitch these together, and then once I got home, I was not at right angles. They would never stitch. I was hoping there was a skyway you could walk up onto and try and take a picture of. I'm actually surprised there's not. So when I was in the gift shop buying some stuff, I recommended that they should put up a skywalk. They probably never will. I'm surprised they have the funding for a floor like this, being a museum in 21st century America. But
could have been a donation by somebody.
I'm hoping so. I don't need to get into politics and things of that nature. That's just not worth it. So, yeah, there is a ton of fun to have in New Mexico, and as I say, one of my main reasons for going there was heading underground. And yeah, lots of caving to be had. I'm glad you're on here, Stephen, because I really wanted to show you this picture. There were a couple of other groups of individuals that were going down into this collapsed lava tube cave that we were heading into. It's maybe a day's worth of caving. It's nothing crazy. It's not like you're going to go and get eaten by weird monsters in the middle of the night. It's easy stuff. I'm not that crazy.
There might be chupacabras. It is New Mexico.
Well, there might be, but they usually come out at night. So we went in the daytime.
Sure. Okay, good. You're safe then.
Yeah, but one of the things that I really thought was cool, since being in Colorado, I spend a lot of time in alpine wilderness, so there's lots of lichen, and a lot of people that have gone hiking in forests you've seen lichen, oranges through greens, spectacular colors. So you see formations like this, a lot of people automatically assume lichens or some sort of a mold buildup. One of the things that I think is really cool about this, being a recently caved in lava tube, this is the actual mineral leaching that's coming out of the basalt. So these colors aren't lichens, they're not mold or mildew. This is copper ore that is leaching onto the surface of the basalt.
Yeah, probably.
So if we're really patient, we should get some stalactites.
No, you won't. You won't.
What if we're really, really patient? How about that?
There's no calcium carbonates in this particular type of a mine. It is all basalts, but the mineral leaching is very cool. It shows it's just kind of one of those neat things where so many times you see colors in rocks and you think, oh, it's this, that, or the other thing, but to think about the fact that this is copper oxide, effectively.
You know how you can tell if it is? You just go up there, you rub your hand on it, and you rub your fingers together, and you smell them, and you'll smell it. You'll smell copper. That's how you see if that's actually what it is. Just so you know.
See,
there you go.
I was sure you were going to say you have to lick it.
No, that's salt.
With your sense of humor, I figured you would just see if somebody would try it.
But lava tube caves are fun, but they're short-ended. This one in particular, it's got about 20 meters of ice in the base. There is one crevice if you really want to get into some tight squeezes, but there's more caves that are a lot more fun. But this isn't a spelunking show. This isn't a mountaineering show. It's not a rock climbing show. I wanted to toss a couple of those out there because it is actually a really amazing region altogether. Some of these basalt flows. Let's see if I can. So this is the caldera of the cinder cone that actually produced that cave. So this was a good maybe 1,100 vertical feet and probably a half-mile linear from where that cave was. And this caldera is just absolutely beautiful. It's a good 1,400 feet across. It's no Mount St. Helens. I might be going the wrong way. Nope, I'm going the right way. Anywho, these are basalt flows from it. It erupted much in the same fashion as Mount St. Helens, so it wasn't a pyroclastic flow, obviously, from those basalt flows. It was very much a catastrophic explosion, but not a mountain caving down and boiling mud spewing everywhere. It was lava, much like you would see on Mauna Kea, like today or yesterday. Again, these are all mineral leaching. Sorry, I have a addiction problem with my camera.
Oh, that's okay.
So the cinder cone's absolutely amazing. It's a short walk to it, and from when you drive into this particular area, of course, a lot of west central New Mexico is covered in basalt flows, is very, very highly volcanic, and this might actually lead into, I believe we were talking about doing a show on volcanism, Stephen. So this might be a fun one to tie into that.
Yeah, it would be. Do you know why there's so much volcanics there?
I don't.
I believe that falls within the Basin and Range province. The continent of North America is showing the onset of rifting in that area.
Okay.
That's why you get a lot of volcanism. It's not from the laramide orogeny. It's not from the formation of the Rockies. That's not what it is.
Gotcha. Yeah, I think we definitely need to do a volcanism episode. That'd be a lot of fun.
At least I think it falls within the Basin and Range province. I'm pretty sure. I'd feel like an
Well,
idiot if it
you're the
didn't. But I'm 99%
geologist here,
I'm
so.
sure. I'm 99% sure it does fall within Basin and Range province.
I make machines. I don't study volcanism. I will take the geologist's word, and we will do a little bit more research, and
I'm
we will
looking
definitely
at it
have a
right
show
now.
on volcanism.
Cool. It is Basin and Range, that area.
Nice.
Okay, so I just confirmed it.
Awesome. So overall, the caldera is about 18. It was a little over 800 feet deep, 1,400 feet wide. So obviously, comparing it to something as catastrophic as Mount St. Helens is no. But it's a similar type explosion where a cinder cone did just belch everything that it had available, and its basalt flows run about 30 miles through the valley, and just you can imagine from one cinder cone back to the one that exploded, the depth of that, being that cinder cone having a cavity 800 feet deep, and then the basalt flows that it spewed being taller, being higher in elevation. That was a massive eruption. It must have been absolutely catastrophic. And fun little historical note about this whole region and that cave in particular before jumping on to the last bit of science for that point in time, or for this trip. The region that this is in used to be known as the Devil's Playground for the sheep herders that were original settlers. I'm sure there's more than one reason to that outside of the basalt flow. But one of the things that I found historically very interesting was that the only reason for actually settling in this area, well, no one else lived there, so cool, you get to live there. It was the ice in that cave that I showed earlier. It allowed sheep herders to have a saloon with cold drinks.
Nice.
So the entire tourist attraction that wound up leading into that at a later point in time, and all of it being a destination for people to go to, was based upon you could have cold whiskey in the middle of the desert, thanks to basalt.
Yes, and Andy, it's really cool that you actually got to go into a basalt tube, a cave that's, because vast majority of caves are limestone caves, and most people don't actually get to go into lava tubes. That was cool. Thanks.
Yeah, it was a lot of fun. Limestone caves, you get all the calcium deposits, you get amazing stalactites and stalagmites, you get all of the soda straws, you get the bacon, and no, not the strips of pig that you cook. There's a structure that you call bacon in caves. It's beautiful. Ribbons that look like candy, and there's amazing things in limestone caves, but basalt caves are, I don't know, they're completely different. It's a completely different animal. It's not a cave because of erosion. It's a cave because of formation.
Yes.
It's really cool. So of course there was tons of fun with that. Of course, there's canyon lands, huge rifts in the basalt flows. It would have been terrifying to be in this region when this particular volcano decided it was going to blow its lid.
Yeah, you'll start.
So
You'll
many
start
pictures.
animals.
I probably don't need to go through all of them, so I'm going to go ahead and move on to. It wasn't the last stop, but it was absolutely one of the most phenomenal along this venture, and it does tie into the last couple of weeks of what we've been doing on Sunday Science, and that would be the Very Large Array. So for anyone who's unfamiliar with what the Very Large Array, obviously its acronym's pretty easy to figure out, VLA. If you ever watched the movie Contact, you've seen the VLA in a movie. If you've ever sat down and looked at a very highly detailed image of a radio emitting galaxy, or things of that nature, there's a very good chance that imagery came from one of the, I want to say 27 of these 83-foot dishes. So you can imagine, this is the repair hangar where one dish at a time can actually move in. This is a tour bus. This is a tour bus that you would see Motley Crue driving around in. And this is the hangar for these dishes.
That's a big box.
If you have ever thought about heading out to the VLA, or if you are interested in learning about radio astronomy, we are going to have links in the description that lead back to much of what it is that we do here, but there's more education behind it than a lot of the times we're able to get out. So there's going to be a fantastic link in the description that this comes directly from the VLA, because of course scientists all over the planet are always interested in helping people get into the explorative nature of being an inquisitive human. It's so much fun to go out and learn new stuff, see stuff, and the VLA is absolutely phenomenal. I'm so glad that it was on my bucket list, and it's one of those things that I was able to sit down and do, because even driving into this region, it once was a lake bed during, I don't know which of the last, not the most recent ice age. I want to say it was closer to two major ice ages ago. So of an oddly flat part of the world, you can see weirdly far. There's a couple of pictures there I am going to skip. So while I was at the VLA, they were in the midst of doing a software and hardware update, which you can imagine when you're dealing with radio telescopes of this size, a hardware update and a software update simultaneously, it might take you 9 months, 18 months. It's a project. It's a huge project and a huge undertaking. Each one of these 83-foot in diameter dishes actually moves about a rail car. So what they were doing while I was there, there's four different placement zones that you can think of like a camera aperture, and they're effectively positioned D, C, B, and A. And as you go from the tight net circle that you're starting to see here, this is only one of 3 legs. So they were getting a single of 3 legs into position on this. It's like the zoom lens on your camera, and you're going from looking at something far away that's fuzzy, and then you're opening that aperture, you're opening that zoom, you're changing the amount of light being let in to hit the sensor, and you're going from what is a 0.6 mile diameter to a 27 mile diameter aperture. And it is unbelievable. So I'm sorry, there's going to be a multitude of pictures of every single position that I possibly could think of taking pictures. So this shows that basically it's a alt-azimuth gimbal that's sitting inside of the repair facility, so you can move the telescope around in alt-az. Oh, they're so huge. Whoop, went too far. Whoop, went too far again.
You've gone too far this time.
I have. So with the way that both SciStrike and myself are building our current radio telescopes, we're using a single reflector, a traditional, satellite TV radio dish, and it goes to an LMB. The signal starts to get processed. Well, with a dish like this, you're working much more under what you would consider Muskov Cassegrain. My mouth hates that word. It's a dual reflector. Sorry. I've had a couple of beverages, and I'm not going to be able to pronounce that correctly. But you have a signal reflect off of one parabolic surface, second parabolic surface, and you get into the actual receiver. I will show what's up in this spout. It's the horn. But when you come into the actual receiving electronics, this I was lucky enough to get schematics of how this functions because, you know, it's Public Science Foundation information. So really all you got to do is go there and you can learn all about it. I will try and help teach as much as I can, even though most of it is, when it comes to radio astronomy, this is beyond me. I'm still learning. But that link that Sai's going to pop in the description, it is just flooded with learning materials, and that's all provided by, you know, all of the astronomers that work at the VLA and astronomers from universities across the planet. Amazing source of information, and it's all free. You really can't ask for more. So up on the top end, this would be the horn. So the same way, if you sit down and if you want to build a Newtonian style reflector, you're going to have a baffle here and there. If you build a traditional refractor telescope, not a reflector, sorry, refractor telescope, you're also going to have baffles, but dispersed over a much shorter amount of, or a much larger amount of space. Obviously, these baffles are, I mean, these were maybe a half-inch spacing. So they're a tremendous number of baffles, but you're not trying to stop reflected or refracted light coming in at an angle. You're trying to deal with radio waves that are moving at obviously a completely different frequency. So you have a tremendous number of baffles in place before getting any signal processing in. Again, I do have some schematics on all this. So again, this was just a general voltmeter. It's part of how a solar radio telescope functions, which I had never thought about before, using effectively optically visible wavelengths to actually take any sort of radio measurements. As well, the LWA is a new addition that the last time I was here, when I was a kid with my dad, the LWA didn't exist. A decent number of the things that all of the VLA was capable of didn't exist back then. It's been a long time, but the LWA is absolutely phenomenal. It's a series of these antennae, and these were, unlike the large dishes, they don't move. They're stationary, and they view everything in the night sky. Rather than get into them, I'm going to hopefully leave some curious minds that want to look into it. So in this one, these are some of the concrete pillars that these dishes actually wind up resting on in between moving along the rail cars. I don't want to spend too much time, but you can see some of the distance from tower to tower. These dishes are able to spread, like I say, from 0.6 miles to, yeah, that's still an 83-foot wide dish. Way out there. Up to 27-mile diameter. So you pull into this valley and they're everywhere, as are the antelope. Watch out for them. So, of course, they were going from the A configuration, which is high resolution, to the, yeah, still dishes all the way out. I would zoom in, but it just gets blurry. Cameras only have so much resolution. And yes, they were bringing them all in close. So this little red guy here, that's one of the dual rail cart cranes that actually moves these dishes around. And from my experience there, it was about one dish a day going from A position to D position, which again, that's a 27-mile diameter array to the 0.6-mile diameter array. So I can see why you could move a dish a day. Just more close-up pics. So this is transporter 2. It was rolling by to go grab another dish or stage itself for grabbing another dish. So there's 2 of these. They're custom-built rail cars. They're engineered specifically for the task of moving these dishes about a triangular array. And they're really cool because you think about, one, it's a train that runs on 4 tracks instead of 2. And you can see something's a little bit weird with the way that these wheels are arranged. And something's even weirder with the back wheels and the front wheels. Well, basically what this guy does, it moves on a linear track for the majority of the time, but then it comes to a perpendicular stretch, and the entire mechanism is actually lifted on pivoting wheels. The wheels pivot, and you can see this crazy cross-section-y portion of the railroad track. The entire vehicle turns 90 degrees.
Nice.
On these separated sections of rail track.
Where's the engine in that thing?
It's all diesel electric back here.
Okay.
And which actually kind of neat, when you're down there and you get close-ups of the dishes themselves, each one of them has what appears to be made for a house AC unit attached to their electronics. That was really cool. I think I have a picture of it. You can imagine how hot it gets and dealing with basically having a small supercomputer in a shed. But yeah, it's real fascinating watching these things move around and pick up telescopes. This entire upper section actually slides back and forth along this trackway as the wheels pick up and rotate 90. Oh my gosh, it's an engineering awesomeness.
I had no idea that existed, Andy. This is I think I've learned something today.
It's really cool, and so here's one. It was in the midst of pivoting. It was pivoting out from having placed. I believe it was this second one in this dish. I think that was transport number 1. Transport number 2 is already coming up my way. So it was still in the midst of actually lifting itself and rotating. Oh my gosh. These things are so awesome. And, so there's a size comparison. These guys were watching me take pictures. There's some of the technicians, obviously, sitting down and mounting the dishes after they moved on rail car to these concrete pillars. And there you go right there, actually. There's a regular household air conditioner unit for your central air. And its entire purpose is just to keep electronics cool inside of this whole region of the telescope. So each one of these 27 radio dishes all have the same supercomputers inside of them processing data. It is such a phenomenal sight to see. Yeah, you can see all the way out, just stretching for miles in the distance, and I'm not even joking. These are dishes for miles. I mean, for basically what, 13.5 miles out, each one of that's a dish. That's a dish. That's a dish.
Looks like
that's a dish. That's a dish.
Gee, Andy, I'm jealous. I was I was in awe out at the laser ranging facility by Goddard where they just have one, and seeing it swing around to a different target. I think it was every 2 or 3 minutes, and I don't mean like 3 or 4 degrees. I mean like 30, 40 degree swings. And the speed of that massive object was just amazing to see it swinging around. But looking at this, I'm jealous,
Yeah.
Andy.
It's a lot of fun. So number 24. Sorry, I'll back up to
235 tons.
Yeah, the number 24 is part of the permanent exhibit. I believe that effectively means that it's the central point or next to the central point. I believe this guy over here was actually the nexus of the array, if you will. But 24 you get to walk right up to, so obviously you can see the scale of the staircases. And yeah, so foundations are roughly 2 meters above the track, 10 meters deep. So those concrete pillars, those go another 30 feet in the ground just to support these things. There are people that live in buildings with weaker foundations. Oops, wrong way.
Yeah, they probably have to put that in the bedrock, don't they?
Probably, 15 arc second tracking in wind, 18 miles an hour, hitting an 83-foot diameter parabolic dish. 18-mile-an-hour wind doesn't seem strong, but when you have that much surface area pushing against it, that is a tremendous amount of force. Yeah, and as SciStrike said, 235 tons each. So you can imagine that's why you need a device like this to pick the dang things up and move them from place to place. They are just unbelievable. And so this one, of course, you're going on a walk path tour, so you get to see the what they're talking about. So these are obviously satellite images. So I'm at the red dot. So pretty sure that means it's not the dead center. I thought it was one dish over. This confirms I was one dish off center. So in configuration A, so I thought it was 27. I guess it's 22. My bad, but you can see obviously it's able to collect extremely high resolution of whatever it is that people are working on imaging. In the B configuration at 7 miles, again, these are satellite images. You can hop on Google Earth and you can see the train tracks. You can see the array.
Yeah, I'm on Google Earth right now. The most recent ones, it looks like they got the dishes in like mid-tilt or whatever. They were moving, and so you see 2 overlaying images. It's kind of cool.
Nice. That'd be very cool. Oop, wrong way. So yeah, and then C configuration, 2 miles, obviously resolution just keeps degrading. So you have this real high resolution imagery. Like I say, it's the same as using a telephoto lens. But when you're just doing a software update or you're reconfiguring, of course, you don't want to try and take the most high-res picture you can. You just want to make sure you can take a picture well. So the deconfiguration is where everything's packed in as close as it can, and it's hard to see, but even compared to, what was that, the 2 miles, 0.6 miles, it's not a very large area. And as you move across in that satellite data, and your aperture just keeps getting larger, and too big to fit in the picture. Yeah. It's an absolutely amazing place. I highly suggest if anyone ever gets the opportunity to head down and take a look at the VLA, you'll have the same look on my face as I do in this picture. You just don't get to see my face.
I assume
again,
jaw has
I was
dropped.
just looking at the AC unit. It surprised me.
Because it looks like the one at your house?
It looks exactly like the one in my house. There's also a lot of other fun there. So like I said, there is a there is an actual solar radio telescope, and it's on a traditional all-azimuth mount. So up here, all you're looking at is a basic DC voltmeter. The electronics inside it's a very similar configuration to what was going on in the horn with the baffles I showed earlier. This is actually one of the projects that the link provided below is you're able to do as an amateur astronomer. All of the reading sources necessary are available through the Astronomical Society. It is a phenomenal tool. You won't be disappointed, and you do get to, if you go to the VLA, you can sit down. You actually get to move this thing around. You get to play with it, and you get to look at whatever you want to look at. Granted, the sun's the easiest thing, so you get to do all that. The electronics, back to the electronics. As you slew the scope around the sky, you can actually watch the voltmeter jump around. And obviously it's jumping around because as signal strength increases, I'm not 100% sure what's taking place inside the box as far as that circuitry is concerned. I know there's links to it. I looked at it for a little bit, but not completely. But obviously the voltmeter is going to jump around because the frequencies that you're viewing, if you look directly at if you point it at the sun, don't look at the sun. Use the shadow that it's casting down here on the concrete the same way when you're, during the solar eclipse. Don't look at the darn thing. Try and make the shadow as small and perfectly circular as possible with your telescope with the solar filter, and take pictures. If you blow up a camera, it's fine. You'll still have your eyesight. Don't look at the damn sun, ever. Sorry, I have to stress that one.
Safety first.
Yeah, and yeah. But it's a whole lot of fun to sit down and tinker with something of that sort, because it kind of shows you one of those introductory things to radio astronomy that I will touch again on later in another show, but that has to do with a particular anniversary that's coming up when it comes to spaceflight as a whole, and I don't want to ruin that. So not going to get too far into that one, but you go to the VLA again, they're not trying to, like all science institutions, they are not trying to hide anything. They teach you how their resistors work. They teach you everything about how basic circuitry works. When it comes to even sitting down and building your own amateur versions of these, it is by far one of the coolest observatories I've ever been to in the flesh. I thought someone said my name. Was I wrong?
Ken, if you want.
Yeah, sure.
Andy. Look at that. They give you the they give you the
I
block
was looking
diagram.
at that diagram.
Yeah, me too. I'm real close to the screen trying to. Not as common.
My glasses up, trying to.
You can always watch it again and take a screenshot of it, and then you'll have a picture of it permanently. I didn't want to rush through some of these too quickly.
Understandable, but nice to give you a block diagram. And actually, that's the actual schematic.
Yeah.
Nice.
Yeah. So it's an amazing observatory to go and visit. Being an amateur astronomer, of course, I've always wanted to go, and hopefully one day I'll get to go to the Atacama Desert and see ESA's everything.
Yeah, we all want to see that one.
And hopefully someday I'll go to Hawaii and not get the crap kicked out of me by locals, and I'll be able to get up Mauna Kea and go to the Keck. But I would rather respect the indigenous peoples, and if they don't want me going and hanging around there, I'm perfectly acceptable with that. I'm perfectly okay with that. But I would love to go see the Keck. I would love to go see a lot of observatories, but if you don't get the opportunity, but you do get the opportunity to go to a very eclectic observatory, I absolutely suggest the VLA, the Very Large Array in New Mexico. It's never busy. It is a ton of information available, an immense amount of learning resources. Everyone there is extremely friendly. Oddly enough, it's actually one of the most populously inhabited telescopes on the planet. As you can imagine, having to move all the telescopes around, running a museum, all of the technicians necessary to sit down and work on this instrumentation, maintain the vehicles. It's one of the most heavily manned observatories on the planet. It really is something different as opposed to going to your local university's astronomy club and, hopping on a half-meter Ritchie-Chrétien is absolutely amazing, but going out and seeing radio telescopes of this nature it's breathtaking. And like I say, if you have the opportunity, I absolutely suggest it.
I did. Now you got me making plans over here. Andy, Bo says, just go and visit Canberra. Oh. Okay, ready for another vacation?
I can take a week a year. Sometimes I can squeeze in a second week as long as no, don't need to get into the finite details. Generally, I can get a vacation a year, 1 week at a time, so most of my vacations take place in the States, unfortunately.
Well, at least you got to see some cool stuff, unlike our last trip.
There's a lot of fun stuff to see, and if the videos you put up are any indication of some of the awesomeness that you got to see, Stephen, I'm pretty jealous of a lot of that sandstone. That just looks like beautiful country.
Yeah, you like that sandstone. Yeah, it's beautiful.
It
I
is.
was referring to the floods on Father's Day. We were up. That's all.
Yeah, the flooding can be catastrophic. Absolutely.
Yeah, that was pretty bad. But I'm glad you like those because I'm gonna get more pictures of those. So I'll have more.
Absolutely, that was definitely a fun one. It's one of those growing up with a geologist for a dad. It was like, what about this? Shut the hell up! You don't know what you're talking about. Okay.
That picture you saw of the red sandstone is actually from my paper. I took for the paper.
So, that's fine.
There's two ways to get to those cliffs. You have to do it by boat, or you have to crawl down very carefully, and it's really hard to get back up. So,
yeah, crawling down sandstone doesn't sound fun. I would definitely go boat.
Yeah, we were dumb enough to climb down because we were stupid. But we got up, so we got down and up with no broken bones. So,
if you can climb down and climb back up, I've done a lot of rock climbing when I was younger, and it's a lot of fun. But sandstone, I don't know. That's yeah.
Yeah. So,
no, that video was a lot of fun. That was very informative. I like it a lot. If I'm sure a lot of people have no idea what we're talking about, so you're gonna have to jump over to Stephen Bauman's. I hope I just pronounced your last name correctly.
Yeah, exactly.
Okay. You're gonna have to jump over to Stephen Bauman's channel and take a look at some of the last episodes he's been putting up. I'm pretty sure this is actually where you plug yourself and I don't plug you.
Oh, I'm supposed to plug myself.
Hey, we do it on movie night. We might as well do it here too. It was.
I really didn't think about anything to plug. I'll put my channel link in the comments once it comes up, if it does. I'm having issues here, but yeah, like Andy said, my last video, I do this thing called the Geo Files, which is kind of like a series. This is that I do. I do several episodes every year. This is the second year doing it, and what Andy's talking about, that sandstone appears in episode 3 of series 2, which is called Casting Doubt on Snowball Earth. Because I've never been a very big fan of that whole hypothesis anyway, as I've told many other people before. But yeah, that red sandstone that Andy saw in the video and he's talking about puts a big, huge wrench kind of in a whole snowball Earth thing, now that we have dates for it. So, but yeah, if you want, just go over there. There's stupid stuff on there too, like us building a deck and all that other stuff too. Saving turtles, that kind of stuff. But most of it is rock porn. All right, I'm done.
Oh, very good.
Nothing wrong with rock porn.
Yeah.
I would agree. Alrighty.
All right, well, Sidestrike, I know that you recently got a decent portion of your new radio telescope that you've been working on built. I know we're closing in on our, well actually we've elapsed our normal hour, but do you want to share progress that you've made as far as your build?
Sure. It's hold on one second. Let me get that going here.
Oh yeah, I can probably stop sharing at this point.
Yeah, I'll switch over to the image, and then I'll share the screen so you can see what the hell I'm talking about.
Oh yeah, I get the chat back now. Holy crap, I missed a lot.
Yeah, you did.
All right, here, let me...
I'm going to have to figure out a different way of doing that.
Here you go.
There it is.
Tell me when you two fine people can see that.
I see
Got it.
The dish's backside, so avert your eyes. Anyway. This is a regular DirecTV satellite dish, and it's mounted on an equatorial mount. And,
now, is this the same EQ mount that you used for the Eclipse video?
In fact, look at you're the sharp one tonight. Yes, in fact, it is. As evidenced by that horizontal bar that you see there, that horizontal aluminum bar, that was during the eclipse. We were all gathered at, invited by Sean Hufford to his aunt's place, right in the zone of totality. And what a fine group of people to be with. Anyway, this was the rig that I constructed for the thing. It's a regular equatorial mount, so it could track the sun on motor drive. No computer, no complication, just a regular old motor-driven equatorial mount. And that horizontal bar had four cameras across it. One video, one DSLR, one wide-angle action cam, and one narrow field type action cam. And the wide field one actually ran out of batteries. But in any case, the reason that I kept that mount is not too long in the future, we've got another eclipse coming up. And it just occurred to me while we were building this project, wouldn't it be cool to, while you were doing videos of the eclipse and all that sort of thing, if you took readings of what kind of radio signals you were getting from the sun? So it's all going to be integrated into one. The same mount that was used for the eclipse will have, probably just two cameras mounted at the extremities of the bar. You have to do a little alignment, and we'll have one extra type of device doing measurements.
That does actually sound like a that sounds like a really cool idea, and it made me think of something that might be for balance issues. If you mount one camera to one side of the rod and not the other, or a counterweight to the other, obviously, I'm assuming you would do.
Yep.
A lot of I've noticed personally a lot of not bad model Nikons or cameras, things in the range of 14 to 18 megapixel, but they're not DSLRs. They're just point and shoots with nice lenses. A lot of people seem to be modifying those and getting rid of the IR cut filters for stupid crap like, I'm going to go and be a ghost hunter. I need the IR filter removed. But people are actually doing that, and they're selling them for dirt. I mean, they really are. If you go onto eBay and you look for modded cameras that don't have an IR cut filter, as long as you're not looking for an SLR, there's actually a lot of earlier model Nikons that are perfectly acceptable, 12, 14 megapixel cameras. There's nothing wrong with them, but somebody did mod them and pull the IR cut filter, and they sell for $50.
Hmm.
And then you can kind of get the best of both worlds. You can sit down and you can do radio, and you can have a mix of radio and hydrogen alpha wavelengths on visual.
Just make sure one of them is a P900.
I don't know. Just tossing ideas out.
Just make sure P900, because that's magical.
Oh, yes, the truth detector. Oddly enough, I have purchased one of those only a week before the P1000 was announced. Anyway.
Okay, what's the... I've asked this question a couple of times before on... I know it's generally when we're drinking on movie night, and... What is the actual focal length and aperture of a P900 at full zoom?
I have no idea. I
don't know. I don't know either. And I don't think the people that tout it as a magical reality detector know either.
Well, of course they don't, but it's just one of those... Aperture size is so much more important than anything else. And there's a reason why you wind up with gigantic freaking telescopes in Hawaii and gigantic freaking telescopes in Argentina and Chile. It's...
Light gathering is a thing.
The more light you can get, the more stuff you can see.
Or 3,000. Sue gave two answers, 200 millimeters and 3,000. Now 2,000. I don't know what it is.
Okay.
Which eclipse were you talking about? Were you talking about the 2024 or the Antarctica one in 2021?
Which one of us?
Sai said there's another eclipse coming up soon. Earlier, he said that.
The next one, not in Antarctica. I'm not prepared to travel there for an eclipse just yet.
You want to get on a boat? What is it? I think 2019. There's one in the middle of the Pacific.
Ooh. On a boat. How much luck are we gonna have in maintaining? We're gonna have to buy some expensive stuff to keep a camera steady. On a rolling sea.
I'm not even okay with going and waiting in like Chesapeake Bay, let alone getting out into the real ocean. I'm a mountain guy.
Oh, I don't mind the ocean.
There are giant weird animals that live in the water. I don't do that.
Yeah, but they're cool. Watch what is it? That BBC show, Blue Planet 2? Yeah, there's cool stuff down there.
Exactly. I can watch them on a show and be alive.
Where they can't get you. Angry Architeuthus.
There are no crazy sharks or other forms of life, especially those that happen to be protoplasm, that can reach me in Colorado.
Ah, I see.
I don't like jellyfish.
Jellyfish are large.
Well, Andy, come to Lake Superior then. You ain't got to worry about that crap there.
I'm totally okay with a giant inland freshwater sea.
Oh, good.
That doesn't bother me at all.
You know what we've had lately here, at least here in this part of the U.S., lampreys are getting a little happy and swimming up into freshwater streams.
Actually, Si, now that you mention that, they've been found in Lake Michigan.
That's just damn impolite. When you go swimming in a river, you expect to, the occasional turtle. You don't expect to have a lamprey stuck to your arm.
No, those jerks.
It's just really.
Oh, as a matter of fact, if you watch my video on the research vessel I went on, they had one in a preserved that they pulled from Lake Michigan.
Freaking
jerks.
Well, yeah. Anyway, all right. Let me blow through the just construction. It's not for anyone building along. I'm sure you figured out. It's whatever tripod you can get, even if it's just a simple gimbal and you have to point it manually. The
Oh yeah, if I hadn't left my photographic tripod out, it was a retired Bushnell, cheapo telescope, but it works great as long as you know how to use a right ascension mount.
Indeed.
The thing rotted out. It never could have carried the weight of a dish, but I'm still figuring out how to program the one that I've been building for the last 2 years. That project just consumed way more than anticipated. But same kind of thing. I'm going to look at just a basic right ascension driven. It's not a go-to. It's not anything of that nature. It's from a 1980s Meade telescope. It's a motor and a gear package, and it happens to have a 1/4-20 that you can screw a camera or, make a pillar that you can mount whatever you want to onto it.
Indeed.
That's good enough.
And
it's free. That's the best part. It's free.
Free is good.
People just don't want crap sitting around.
Absolutely.
And they don't know what it's worth, so... Which, honestly, a 1980s Meade right ascension powered telescope mount really isn't worth anything. The fact that it functions is kind of a miracle. Yeah.
Anyway, you mentioned the mount from an inexpensive telescope. This one, I have no idea why this particular mount, because it's really fairly sturdy, and it came with. In this picture, you can see the counterweight for the telescope at the bottom there. It actually came with 3 of those in increasing size. This is the smallest of them, and I have no idea why. Because the telescope, I bought the thing because I needed the tripod, and it was the only thing I could get in a hurry in one of the local shops. And if I just wanted the mount with the clock drive, I would have had to wait if I ordered it from somewhere. So it was just as cheap to go buy this. And believe it or not, on this relatively sturdy mount was mounted a massive 70 millimeter refractor.
There's.
I have no idea why they built the base is built so sturdy, but anyway, this is the animal, and here you can see in this picture that right now the mount for the dish is held on with hose clamps until the first actual test, where I find out if it can be aligned with the cameras mounted as they were during the eclipse, which in this case is 90 degrees to the surface of that flat square aluminum stock there. If the dish can be aligned with where the camera is pointing, then I drill the aluminum and bolt it down all nice with brass screws. But for the moment, it's just held on. The dish part is held on with hose clamps until I can be sure of that.
No, hose clamps are reusable, quick adjustment.
Mm-hmm.
Nothing wrong with that.
Indeed. If I need to make any adjustments before final assembly, I can do so.
The one thing that I did want to toss in as far as how in the world can, sometimes a mount that doesn't seem like it should be able to support the weight of something function. A lot of that obviously has to do with longevity. If you overload a mount and exceed its capacity, it will handle it, depending on how far it's overloaded, for a X amount of time. Eventually it will fail.
Quite true.
Depending on this particular application, when you're considering how it is that a designer would sit down and look at how am I going to reinforce the bearings on the declination axis, if you're counting on having a heavy weight in the back, let's say a large reflecting mirror and optics, you might have a very high weight rated bearing that's rated for axial and radial load on the tail end, but of a more inexpensive and affordable bearing on the front end, due to the fact that it's only going to deal with minor radial loads as opposed to, or sorry, minor axial loads as opposed to radial loads. So a tail end bearing is going to take axial load, a fore end bearing is going to take radial load. And then when you exceed that, it's very easy to do so. Both of those bearings are rated for probably 25% more than their rating. So if you say this mount can support 25 pounds, it can probably actually support 75, but for a limited amount of time.
Indeed. Greater the stress,
so
the shorter the
that's
lifespan.
one of those things that it's easy to get caught up in sometimes, where it's like, well, this thing says I can put 50 pounds on it, but I just put 500 pounds on it and it didn't break. It's like, well, not yet. It will.
And another,
I'm not saying your mount's going to break, but just in general, when you're looking at homemade projects of that nature, if you do notice something has a rating, of, let's say 100 pounds plus or minus 25%, if you're going to go and put 100 pounds on it, you might want to take the time to replace those bearings. There's a lot of standards that exist in the world of engineering. You can hop onto a lot of dealers' websites and buy new bearings, blah, blah, this, that, and the other. Just because the bearing or, the instrument is rated for, let's say, 100 pounds, the materials used in the exterior construction can probably handle 10 times that load. It's the internal components. So does the DC motor have the torque? Do the bearings have the radial support necessary? Things to keep in mind when you're sitting down and doing those projects like this, because a lot of times you can buy a more economic grade, basic powered right ascension mount, and upgrade the bearings, upgrade the shaft material. Of course, everybody likes the idea of stainless steel, but stainless steel has a lower flexural modulus than carbon steel. Up it to a 400 series stainless instead of a 300 series stainless. It will rust outside, but you get that added weight increase that you can place onto the tripod. So, sorry, I'm going off as an engineer and thinking about stupid shit.
Not at all. I would cheat and just use really big oil lights. Anyway.
Yeah, that works too.
Yeah, we don't need no stinking ball bearings. We got oil lights. And no vibration with oil lights. Anyway. Another thing that Andy's mentioning about premature failure of one's homebrew device using any of these kind of mounts is Andy's certainly right with the overstressing the components can lead to premature failure. In addition to excess weight, one thing you can do to that if you have an overbuilt mount you don't need to, is balance. Balance is critical. I mentioned the, where the hell is it? Where's the counterweight?
Absolutely.
Where the hell is it? Is that in that picture? Yeah, you can see it in that picture. Making sure your system is balanced makes it easier for all of the components to deal with it. On both axes if possible, in a mount like this. And alt as, all bets are off. Anyway, so this is it in its present state, and here it is, absent LNB at the end. Now, this was all done, finished, earlier last week. I was just waiting for some components to arrive. The LNB has arrived.
Very awesome. Obviously, this started as a dual LNB, and instead of dissecting instead of dissecting a dual to make a single, you took I would say, the wiser route of just buying a single LNB.
Yeah, and the the ones like this that have the two outputs on them, you can get what's called we would call it a dummy load. It's a 75 ohm terminating resistor to screw onto the additional connector. Some single LNBs will have two connectors on them, and you don't want to leave one unterminated just because it's it's expected that the impedance of the device matches the impedance of the transmission line, which is that 75 ohm coax that you see in all cable TV and satellite TV installations. So if in your projects you happen to have two, but you're only using one of the connectors, it's sort of important to have the second one terminated, because much like with light moving through air, when you get mirages and such, if there's a change in impedance along the transmission line, you get reflections and distortions and all sorts of bad stuff. Anyway,
Yep.
I would have had some sort of results to show today. It's good that we didn't, because look, we're 35 minutes over our regular time. The reason for it is the LNBs are powered devices. One is their down converters, and they require a power source. Normally, that is provided if you have a satellite set up at your house. Normally, that's provided by the box that sits on top of your television. Not using one of those, you need one of these little fellas, which I also ordered up, but did not arrive. So,
Okay, now I do have to, are you talking +5 or +12 on that little guy?
oddly enough, the
Or is this
LNBs.
something weird as hell?
It's something weird as hell. Good that you good that you asked that. LNBs run on some run on it's like 13 or 18 volts.
Oh, fun.
And that's this is for the DirecTV ones. This is an 18 volt inline, and it has minimal signal loss. But already from the LNB, you're getting an amplified signal out anyway when it does the down converting. The plan is to have the dish with the LNB, cable running, back indoors here to where the computer sits, where this thing will be providing power through the coax to the LNB, and then on the output side of this box that you're looking at now, the power insertion module will be the what I'm going to be using is a USB oscilloscope that I think I ordered up a long time ago. Had no idea what I was going to use it for. This is what I'm going to use it for. It has an output that'll let you track levels and output it in a CSV format, and then we can convert that to a graph afterwards. Anyway, that would be the update. Hopefully, by next week, I should have a functioning unit to show you folks. But that's what I got, Andy. Aren't you sorry?
Yes. You're still a step closer. I've not had a chance to order my SDR yet.
See, I may go that way too. I'm sort of liking your idea better, because the software for that device that you're going to be ordering, the little software-defined radio, first off, it's a great price for that thing.
It really is.
But secondly, the software that it just directly receiving at RF, it'll give you the S meter readings, and you can tag them. You can output them again to a CSV directly from the RF. What I'd be doing with the USB oscilloscope is sort of cheating. And basically, I'd be just measuring the peaks with the scope and outputting those. So I've really been thinking of following your methodology there and ordering up one of those as well. But we'll see. We'll see. Maybe we'll each try one and see which one gives better results or something. Anyway.
Right. There's absolutely no reason to diverge from the scientific method just because there might be a way to do it other than the way you've already started.
Indeed. I would tend to agree.
I've built a lot of things that failed, and then I looked somewhere else and went, But now I learn. Now I learn something new. Every time I fail at building something, it's because I needed to learn something, as far as I'm concerned.
Oh, Heat Shield. Heat Shield says he has a dual LNB and no idea how to convert it. Well, first off, does it look like... Hold on. Does it look like this, Heat Shield, just with two outputs? Or is it the one with two of the actual feed horns next to each other? We shall wait for a response. While we're waiting for a response, if anyone is building along with us, please not feel free. I would ask you, send us pictures of your constructions.
Oh, absolutely.
Yeah. We'd love to include them in a future episode, and we all get our stuff up and running. And
it'd be a lot of fun to coordinate. Since a lot of us are just kind of all over the map as far as where we live on the globe. A ping from here, a ping from there, a ping from. All that does is give us more resolution. The same way the LMB splits all their telescopes up for greater resolution. It might be amateur radio astronomy, but it increases our resolution to have a team of people working together and sharing ideas, bouncing ideas off of each other, building these things in tandem, helping one another, and having a common goal. It only drives scientific inquiry so much more.
Indeed. I would definitely agree. Anyway, so if anybody is building along, well, we know some people are, snap some pictures of your stuff. And our email is sciencestrikeforce, all one word, @gmail.com. Send them in. And, obviously we'll put them all together and show them on a Sunday Science on whatever day it occurs. So.
Yeah, absolutely. For the most part, should be either Monday or Tuesday throughout the summer. Hopefully, mostly Monday, but
well, yeah.
Sometimes other things. Last week I was really looking forward to having this one last week. We have friends that also like to do hangouts as well, and Vince had a great hangout with LL, and Cap had a great hangout with Mel, and then RJ has a great hangout on Wednesdays.
There's a lot of good stuff going on. A lot of good stuff going on YouTube.
NA gave us super chat of $5.
Oh, thank you, NA.
Oh, thanks, NA.
Alrighty. Well, thank you very much. But,
very awesome.
Anyway, yes. So for future shows, I think we've settled on days ending in Y only. So
Indeed.
we should be, for the foreseeable
but it's still
future.
Going to be called Science Sunday, right?
Absolutely, or Sunday Science.
Science Sunday, Sunday Science, as long as it happens on a Monday or a Tuesday.
Right, and that or Andy's show.
And
what are the
sometime between 4 p.m. Eastern and 11 p.m. Eastern.
Oh, Heat Shield. I believe in the old PDF that is linked in our first mention of radio telescopes on Sunday Science quite a while ago. I'll dig up the link and put it in the description of this as well. They talk about taking a dual LNB and cutting it up and modifying it.
Yeah, there was. Yep.
But I will also tell you.
Man, I'm starting to sound like a Sesame Kid alien. Yep.
I remember them.
Yep.
I will say that this single LNB was gotten. This one that I have received and have installed it came from eBay, and it cost grand total of $6. So I saved myself the trouble of cutting up a dual or triple LNB. So
sometimes going and grabbing one of those freebies from the local yard sale is going to it can save you a tremendous amount of money with the things older electronics can do that digital TV doesn't like, but radio loves. Indeed. Don't waste your money on a lot of things being brand new.
Agreed.
There are treasure troves of awesomeness in all over the place. It's worth the research, in my opinion.
Actually, there was someone not far from here that I saw on I don't know, I think it was on Let Go or something like that had free to good home a couple of the larger dishes and in the picture it had everything on it. I drove by and somebody had snatched LNBs. Like, damn it! I already have dishes.
It's the powered ride Ascension mount. That's a 1980s Meade. Nobody will buy my telescope. Please come and take it. Okay.
I'll help you out. And
I'll I'll be the nice Wednesday afternoon trash man and take that off your hands. Don't you worry about it.
Indeed. Oh, Bo, I think you mean Yesu, don't you? Isn't that your favorite, the Yesus, Bo? Anyway, that's all. That's all I have,
right.
sir.
Yeah, we're 44 minutes past our normal scheduled time. I thank you guys all so much for sticking through this long episode of Sunday Science on Tuesday. I am a cigarette smoker, and I kind of want to go smoke now, so
I know what that was.
you don't have to stay here, but you also don't have to go home.
So you don't have to go home, but you can't stay here, is what you're saying. Got it.
Yeah.
Okay.
Only in reverse.
All right. Either way. Anyway, well, I'll tell you, with the show running over, with the presentation you did, Andy, I would have stayed for a couple hours. That was very impressive.
Well, I'm glad everyone enjoyed, and honestly, I had no idea that we were as far over in time as we were. And I'm not actually saying, oh my gosh, my nicotine addiction is so terrible that I want to run away. Just, it's been a long show. It's been a decent night, and I am actually getting hungry. I'd like to eat some food.
Andy, an hour 45 to go without a cigarette is a long time.
So, Andy, have you read War and Peace? Hold on, let me read it to you. Sit back.
Okay.
All right.
Is there a way to look up the emergency broadcasting signal on your phone just so I can dump it into my mic right now?
Not that I know of. Anyway, thanks for grabbing all those images for us, Andy. That was. Now I'm thinking of planning a little trip.
It's a phenomenal place to go to. Like I say, there's so much science history in New Mexico. It's not just about radio astronomy. It's not just about nuclear history. There's a lot of development of how our country got into space flight. It's a beautiful place to go and see. It's hot as hell. It's dry. If you're not used to hot and dry and high in altitude, just to give everyone a heads up, the LVA is it's at 7,000 feet in altitude. So if you're not accustomed to being in high altitudes, you take your time on your way, hang out in Albuquerque for a little bit, hang out, at rest stops along the way, get acclimatized. Don't come up from the east or west coast at sea level where you're accustomed to and jump to 7,000 feet and think everything's going to be just another day, because it's not.
You'll poof up like a blowfish.
Yeah, you'll have issues, and it's gonna make the trip unenjoyable. So take your time. Make sure you acclimatize correctly, because a lot of the high desert it's higher than Denver. Like I say, it's 7,000 feet. It's well over a mile. Don't just run out there like, yay, because you might get sick.
Nobody
and
wants
altitude
that.
Sickness sucks. The first time I got it, I was at a good 13,005, and it's even worse when you're up in the Alpine regions. I don't want to know what it's like in the desert, because there's a lot of vomiting and dizziness involved, but I know what it's like in the Alpine, and it sucks.
Indeed. Alrighty
So,
there.
Just don't rush into it. Take your time. Enjoy all the sights. There's a lot of cool stuff to see. There's a lot of cool stuff to learn, and there's going to be a lot of cool stuff to see and learn next week here on Sunday Science as well.
Indeed. Alrighty. I got nothing else, sir. You?
I'm good. How are you doing, Steven?
I'm good.
All right. Maybe we ought to wrap it up then.
Yeah, sounds like this is a night for today.
Indeed. Thank you, everybody, for joining us.
All right. Thanks, everybody, for joining us. It's always a blast to have you with us.
Indeed. Bye, all.